You ready? We want to talk about a little bit about carbon dioxide predictions from models and other climate drivers. The issue here is about CO2, and it's from CO2 from fossil fuels such as coal, oil, natural gas. And the problem is it causing climate change? And the view is it is causing climate change, but to that I would say not so fast. The Earth had a little ice age from the 1600s to the 1800s. And the Earth is still in an ice age. All you have to do is look at Antarctica, even the Arctic or Greenland, lots of ice. So if the Earth is coming out of an ice age, you would expect warming. So is carbon dioxide, CO2, is it really the culprit for warming? Or is it ocean currents? Is the warming caused by changes in ocean currents or something else? Well, the way the concern about CO2 causing climate change comes about is from models. So let's say a little bit about some of the models. I want to just give a couple examples. There's the Geophysical Fluid Dynamics Laboratory Coupled Model, GFDL CM 2.1. There's a general circulation model. You can see this on the web. There's a general climate model, has GCM2, and that's available here, ED GCM, Educational Global Climate Model.columbia.edu. And this is now January 2016, and I just looked a couple days ago, and they still have a 30-day free trial that you can look at. So there's some models you can actually get to and play with them if you want. But the general thing is that the models seem to be saying that CO2 doubles by 2100, and the temperature would increase by a degree. There's also other numbers such as 2 to 4 degrees, or even more at some of the higher latitudes. So there's a lot of what I'd call doom and gloom regarding CO2. But is it really real? Is there anything good about increased CO2 levels? Is increasing CO2 levels actually causing warming? So we just want to ask this simple question. Does increased CO2 do anything good besides the concern over global warming? And here's an example regarding plants. All these trees have been grown from the beginning at the same time and in different concentrations of carbon dioxide. This little guy over here represents the ambient carbon dioxide concentration, which is about roughly 400 parts per million. The carbon dioxide was increased by 150 parts per million for this growth, an additional 150 for this one, and an additional 150 for this one. So you can see from this little scaled model that plants like carbon dioxide. So one of the things that you could say is that an increase in CO2 will make the planet greener. And that may be a good thing because it means more food for more people. But it really doesn't answer the question about how much CO2 is is causing global warming. But it does say that an increase in CO2 will make the Earth greener. So it's not all doom and gloom when you look at it from the point of view of food for the planet. There are clearly things that have happened before and will happen again that have an effect on climate. I just want to come over here to this chart. This shows the Earth going around the sun. As a friend of mine, Rick Henderson, likes to say, figures not to scale. These figures are, of course, not to scale. And I've exaggerated the ellipticity of the Earth's orbit. And what is a surprise to many people, in the northern hemisphere, our winter solstice actually occurs when we're close to the sun. And in the summer, our summer solstice occurs when we're actually further from the sun. And the equinoxes occur when we have the same length of day and night. And from Kepler's law, as the Earth gets in this part of the orbit, it speeds up. As it goes out here, it slows down. And then it comes in here, it speeds up. And I'm exaggerating that, and it slows down. So the seasons, fall and winter, are actually a little shorter than summer and spring. And this is for the current year. In the year 10,000 years from now, approximately 10,000 years from now, all of this will be reversed. When the summer solstice occurs, we will be closer to the sun. The spring and summer seasons will be shorter. The fall and winter seasons will be longer. And again, this is greatly exaggerated, but 10,000 years from now, when winter occurs, when the winter solstice occurs, we'll actually be further from the sun. So what does that mean? That means that we're more likely to see considerable cooling because we're further from the sun, so we're getting less energy. Here, we're closer to the sun in the wintertime, we're getting more energy. And the fact that we're getting less energy here over a longer period of time means that we'll probably have some cooling. So that's a real example of something in the distant future that tells you that the Earth will likely cool in the far future. There are other so that is the Earth's orbit, the tilt of the axis of the Earth, this way here, this way there, have significant effects on the temperature of the Earth and the ellipticity of the Earth's orbit. So that's an approximation, but it's exaggerated on scale. There are other things that could influence, external things like this, that could influence the climate on the Earth. And one of the things that we could imagine is we have the solar system with the planets, and it's moving through the Milky Way. And we could imagine that at some time it might pass through a gas cloud, say of hydrogen, probably hydrogen and atom. And if the solar system did pass through such a gas cloud, the hydrogen would absorb and scatter some of the light, so the normal amount of light reaching the Earth would be decreased. That's something that is a possibility. And one of the very interesting possibilities is cosmic rays. And they may help seed clouds. The Earth is protected a little bit from cosmic rays by the Earth's magnetic field, and by the sun's magnetic field. So if that field of the sun changes, we might have more cosmic rays coming through the Earth's atmosphere. That may seed more clouds. More clouds means more reflection from the Earth of the sun's light, which means that the temperature of the Earth might go down, and this is called cosmoclimatology. And if this actually occurs or not is a question. And if there happened to be a supernova from a star relatively near to the sun, then we would have more cosmic rays from that. That could cause more seeding of clouds, and more clouds, more reflected sunlight, and that would result in the cooling of the Earth. So, although there is doom and gloom about CO2 when you look at these models, I just want to mention that the increased CO2 will make the Earth greener. There's definite advantages to that. And as far as the Earth's climate changing, maybe carbon dioxide in the atmosphere is not such a big driver. It may be more due to ocean currents. Plus other factors. So, when you hear that CO2 is bad, you have to keep in mind the fact that plants like CO2, and all of the doom and gloom predictions are coming out of these numerical models, and there's a question of how accurate they are. And one of the interesting things when people run these models, they like to run them out in the future a way, say like 50 years or maybe 100 years. And in a sense, that's really good job security, because nobody's going to be around in 100 years to check to know whether or not the predictions you made from your model were correct. So you can get the carbon dioxide predictions from those models. You can get some of them off the web, experiment with them. But as far as the actual climate changing from CO2, there may be other drivers.